Okay, so Heaviside function. Heaviside function, first of all, why we are learning these functions. After writing a definition, I will go over to that. UA of x, this is a notation I am taking for this function. This function takes a value 1 when x is bigger than a. This function takes a value 0 when x is less than a. Right? Now a has an importance here because this is a point after which this function behavior gets completely changed. So point of discontinuity is what here? A, right? Point of discontinuity A. It is also called a step function in literature because it's like a step. People also call it as a Heaviside function because one side they think like it's heavy because of a weight 1 and weight 0. Now, how will I use this function and what is the significance of this function in Laplace transform? Any function which is discontinuous at some number of points, we can able to write down that function in terms of these step functions. So they are kind of like a building block. So in order to build anything, you need some basic elements, right? So this will be like building block for every function. So for example, if I have a function like fx is equals to 2 when x is bigger than 3 and 5 when x is less than 3, you can see this function is discontinuous. Right? And what point this function is discontinuous?
3.
At 3 it is discontinuous. Now my goal is to write down this function in terms of step functions or Heaviside function. So first of all, I will make use of u3 in this because it's discontinuous at 3. Now how can I manipulate that and in such a manner that I get f in terms of u3? Can you give me an expression? I want to write f in terms of u3. u3 you know is 1 when x is bigger than 3 and 0 when x is less than 3. Right? So we will use u3. u3 of x is 1 when x is bigger than 3 and otherwise it's 0. So now tell me, you want to cook this function out of this function. How will you do that? Also think this like a switch, on-off situation. It will be on when it's 1, it will be off, it's 0. Also in physics, people take this like a switch and so you want this function definitely to take a weight 2 when x is bigger than 3. So you might say, okay, let's multiply this function by 2. If you do that, when x...
So the u3, when it's below...
You always keep it. When it's when x less, whenever u3 is 0, you always keep the function value, that value to be there. Because no matter what, that value is not going to change. It will always be there. Now whatever contribution then is left, you subtract that value out of that.
But what was our original u function? Because I think that's where we're confused.
Original u function is when it's bigger than 3, it's taking a value 1. Like the step. The step is the original u function, u3 function. So if u3 x is bigger than 3, u3 is 1. And then here you get negative 3 plus 5, which is 2. X less than 3, u3 is 0. So you get just 5. So when x is less than u3, u3 will be 0 and any multiplication in u3 will not give you anything. So you always keep this value right here, the left value. Is it making sense or no?
Yeah, I just got confused which way U3 was 1 and which way it was 0.
U3 is the step, basically.
I had it the opposite direction.
Okay, so then,
That's
yeah.
the problem.
Yeah. So this turns out to be then 5 minus 3u3 x. Okay, so now you try one example by yourself, because if I am saying, you might not able to think that way, but just think by yourself and do this one. You want to write down say this. In terms of step function, how will you write down this? Minus 2 and 8 when x is bigger than 1, minus 2, x less than 1, 8. I gave you easier because now it's 1. Point of discontinuity is 1. So write down this in terms of a step function. Done. So draw real line. If this, oh no, accidentally my hand just minus 2 when x is bigger than 1, 8 when x is less than 1. So this control panel should be somewhere else. Okay, so draw a real line and mark a point of discontinuity 1. Function on the left is taking 8, function on the right is taking minus 2 value. Now u3 will be 0 when x is less than 1. So 8 has to make a contribution like as it is. So you add 8 into u1 function. Now to balance it to the x bigger than 1, when x bigger than 1, function is taking a value minus 2 and u1 is taking a value 1. So 1 plus 8 will be 9, but you don't want 9, you want minus 2. So now 9 you are getting and you want minus 2, so what you will do? You pick negative 10, right? And to get negative 10, you are doing right, which is minus 2 minus 8, which is minus 10. So that's what I'm trying to tell you. That this 8 is not going to change. Because u3 in this range, when x less than 1, is 0. So u3 will not help you to extract the value of function. Right? u3 will not help you to get the function value. So you have to straight away take that value. Now with the remaining, you multiply in such a manner that you balance out the remaining value. Right? So when u3 is 0, this thing cannot give you 8 at all. So you have to add 8 directly. Okay. So the answer for this is 8 minus 10 u1 x. Now you might wonder now what will happen if you have 3 points of discontinuity. So do on the same lines, let me now write a function which has 3 points of discontinuity. So 1 minus 1, 8 and x is less than 2, x bigger than x bigger than 2, less than 5, x bigger than 5. Now this function has a discontinuity at 2 and 5. You can see that, right? And again I want to write down this function in terms of Heaviside function. So I will be taking here now two switches, not just one switch, two switch. One switch will be at U2, So one switch will be, I have to switch the values so that I get a function value. So U2x is 1 when x is bigger than 2, 0 when x is less than 2. Another switch I will be using as U5, 1 when x bigger than 5, 0 when x less than 5. I know that when x is less than 2, both the switch are off. Right? When x is less than 2, both the switches are off. Now if this both switches are off and x less than 2 function is taking a value 1, none of the switch if I on can give me some contribution to the function value. So I have to add 1 straight away with no thinking, further thinking. Because right now both the switches are off. Now what I will do, I will switch on U2, but U5 is off. So think in this, exactly in this fashion. U2 I am this, so there are two switches now, one is on, one is off. So the one which is off is U5, which is on is U2. Okay, so U2 is giving what contribution? When x is bigger than 2, U2 is 1. But when x is less than 2, U2 is 0. So this will help in the region where I want to write down this value. What should I multiply here? And that's my target now. What should I multiply right here? When x is bigger than 2 but less than 5, that is my U5 off situation. So I should add, what I should multiply here to get my -1 value. I should just make use of this one, right? As I did before. So it should be, what should I multiply here? Can anybody tell me? Very good, -2. And what made you think it should be -2?
Because to the left it's going to 1, which would be going to 0. And then to the right is -1, which would be going to 2.
Okay, so basically you use the same trick of the 1 point. What I am saying is, like, 1 you already have it, and if you add -2 into that, you will get -1. Now this is off, so this would not contributing anything. U5 is off, so that's the reason. Here I will now my all switches are on, and I want to get the value when x is bigger than 5. At the same time, I do not want to disturb this value. So what should I add right here? If I multiply this by 9, then again you did the same thing, right, minus this thing. But this is only consecutive value you used, you didn't use the previous value, right? So this is the correct function, and if we generalize the trick which we learned back up here, if a function is discontinuous at a 2 point and function is taking a value, say g1, g2, or let me not take another notation, it might confuse. So let me make this f instead of f4, and let me put the components of this function up here. So then my fx is f1 left plus right minus left consecutive ua of x plus f3 minus f2 u3 ub of x. So you use now this idea and you generalize into a formula. But idea is exactly the same when both the switches are off. You have to get this value, so you will take it as it is, what function value is. When one switch gets on and another is off, then you balance out the previous value with so that you get a right value of -1. And further you do the same thing. Yes?
I just realized that I think that answer is actually wrong with what you have written.
Why?
Because you have it explicit there that switch 2 turns off once you're above 5.
Yes.
If switch 2 turns off once you're above 5, then it's not -1. It's not contributing anymore. We need it to be on always if x is greater than 2, don't we?
No. When x is bigger than 2, it is u2 functions start contributing. So that's why I said that 2 switch is on.
Yeah, but then you say it's
but it's less than 5, so u5 is not contributing.
Mm-hmm.
So that's why u5 switches off.
But doesn't that also say that the u5 or the u2 switch turns off at above 5?
Above 5, no. Above 5, if x is bigger than 5, x is bigger than 2 also.
Yeah, but you say that for switch 2 to be on, it has to be less than 5. You say it has to be greater than 2 and less than 5 for switch 2 to come on. Isn't that what that says?
No, I am saying when x is bigger than 5, both the switches are on.
I'm just confused then on it seems pretty explicit there that switch 2 it only is in effect when x is less than 5.
No, switch 2 is effect here also because you took 9. Otherwise, you would have just taken 8 here.
Oh yeah, I know. That's why I was saying I was thinking because I was thinking when you originally I had it, but I just think that I don't know. I'm confused by the 5.
Maybe the way you confused by these inequality here. Maybe
just the middle one.
Just the middle one.
Mm-hmm.
Middle one x when less than 5, u5 has no contribution. u5 switches off, but u2 switches on. And you have to somehow adjust this value 1 also, which is already had been added to the function. So that's why you do -1 minus 1. So that's why you get -2.
Yeah, oh no, I'm fine with that. It's the only part I have trouble with is I feel like that statement explicitly says that this u2 only applies between 2 and 5. And once you're above 5, it's off again.
No. u2 is on when x is bigger than 2 forever. Because u2 is 1 when x is bigger than 2. So u2 is on completely. From 2 onwards, it's on. 5, 6, 8, 9, 10, anytime. It's on. Because 2 is always less than 5. So in some sense, maybe let's... when u5 switch is on, u2 switch has to be on.
Okay, I get it. I get what my confusion was.
I don't have I'm trying to see some physical way of putting this.
Well, no.
When u5 is on, u2 has to be on.
Well,
that's mathematically here. But...
Well, my confusion was I was looking at the middle and thinking the u2 switch is on between these points, which isn't true. It's -1 between these points. That value is what's there. But
value is -1 of the function, but switch is on.
No, yeah, I agree.
Switches are these two. So these switches we are making use, and in some sense they are building blocks, so you give some energy to each switch, and this energy or weight is multiplied in the front, which gives the function value. I mean, it's very weird to say give energy to the switch, but you see my point, give some weight to that switch particular to get the value of the function. Okay, so but you see how these are balancing out, and when one is off, one is on, and we try to. But in this scenario, it's interesting to see that it was on, but it was off, and that's the reason we only took these two into consideration. We didn't took this into consideration at all when we were dealing till this portion. When we went to this portion, everything is on, so we have to take care of this And hold on 1 second, when u5 is bigger than 1, what is the value of this function? 9 minus 2, which is 7, plus 1, which is 8. Right. So this already had taken care of that extra thing which we were adding. Okay, now let's go to that's too much discussion. Now let's, no, it's okay. Now let's do for sine and cosine the same idea. If the function fx is sine x when x is bigger than pi by 2 and cosine x when x is less than pi by 2, the function is then cosine x plus sine x minus cosine x times u pi by 2. That's it. So right. Now what do we want? Why we were doing all this? Well, as you all are demonstrating it again and again, integration seems to be trickier for you. Now, in order to find Laplace transform, you do have to integrate by making use of definition. But this gives you an easier way out to find a Laplace transform. Let me write down the formula here. Laplace transform of uax times fx is nothing but Laplace transform of f of x plus a times e to the power minus ax. Suppose a is bigger than 0. So this is the way how you will find out the Laplace transform. Now let's do so I would not go into computing the Laplace transform of this function, and moreover one more thing, fs is a Laplace transform of function f of x, deriving this expression. But let's move on to the if you want, let me give you the hints here. So if you use a definition of Laplace transform over this function, then what you will get? Suppose you want to find the Laplace transform of the integral e to the power minus sx times this. Now this function is discontinuous at a, so you break the integral at a. Break the integral at point of discontinuity. This is a proof for this equation, you have it. Then use the definition of ua. Ua is 1 when x is bigger than a. So in the integral which is from a to infinity, place a value 1. Integral which is 0 to a, place a value 0. So you do it by definition, you apply the definition of ua. And then by change of variable, if you do, you will able to get this expression star, which is right here. So if you want to know how Laplace transform of this turns out to be this expression, if you apply the definition, break the integral, use the definition of ua, and then change the variable, you will get exactly this expression. So these are like a pointers how you can get it to this. Now let me do an example in which I have to first rewrite a function in terms of a Heaviside function and then take a Laplace transform of that. So let's write down the formula again. Before that, here's the problem. Give the Laplace transform of ft, where function ft is t when t is between 0 and 5, and it's e to the power minus 5t, or let's take another number because you might confuse it with this 5, t bigger than 5. So step 1, one method you already know how to find Laplace transform of this function. You just break the integral at 5 and use a definition. You can get a Laplace transform. Now that will involve integration. So this will not. Write down the function in terms of Heaviside function. So I will take, the switch will be u5 here. So it should be, ft should be t plus e to the power minus 3t minus t times u5t. That should be my function in terms of Heaviside function. So this always contribute, and then to balance out we subtract t. Okay, so this is a function. Now step 2, use the formula. Use this expression which we have up here. So linearity, we know Laplace transform of Laplace transform are linear, so I can take a Laplace transform both the side of this function. Laplace transform of ft is Laplace transform of t plus e to the power minus 3t minus t u5t. That's the first step. Take Laplace transform both the sides in this function, right? So then linearity, by linearity we can break it. Laplace transform of e to the power minus 3t u5t minus Laplace transform of t u5t. So is it clear till this step what I did? So first I took Laplace transform both the sides. Then I saw that this is addition, lots of addition and multiplication are there. So you can multiply this into this and this into this, and using linearity break them all. Laplace transform of t, Laplace transform of this, Laplace transform of this. As you can see, this is expression is similar to what you have in the formula here. That was the reason you were given this formula. So this is, I would say, is key here, plus linearity. Okay, what is the Laplace transform of a function x? You can get from a table, it is nothing but 1 over s square, where s is bigger than 0. Laplace transform of this. Okay, to find this I will make use of this formula. So my a is what if I compare this with this?
5.
So a is 5, that's right. And what is my function f? E to the power minus 3t, right? That's my function. E to the power minus 3t is my function. Okay, so formula says Laplace transform for translation of a function times e to the power minus ax. So that means this is same as writing Laplace transform of f is exponential function, translation of exponential function will be t plus 5 multiply by e to the power minus 5t. By the way, I think there is one small thing here. Right. So this here, just make this small correction here. This should be your S. This should be your S here in this formula. It should be S here and it should be S here, because Laplace transform eventually should be in terms of S. So I missed this point. So this turns out to be here S. Okay, by using this formula here. Now the last term will be minus t is a function, translation of t by 5 e to the power minus 5s again. And by the way, this looks, my 5 and my s's are coming, looks together same. This is 5 here. Let me write like this. So here you have translation, here you are multiplying your s. So yeah, this is 5 and this is s. Okay, so now I will simplify this expression. 1 over s square plus, now you can see this is e to the power minus 3t, e to the power minus 15. So e to the power minus 15 is a scalar and Laplace transform is linear. So I can write down it as e to the power minus 15 Laplace transform of e to the power minus 3t, because it's a scalar and Laplace transform is linear. E to the power minus 5s. The last term, Laplace transform of t plus 5 can be further written as Laplace transform of t plus 5 times Laplace transform of function 1. I'm showing every step, so otherwise I could have very quickly written it down, the expression, but how we are breaking it, linearity, every time linearity. So what is the Laplace transform e to the power minus 3t? 1 over s plus 3. So this turns out to be e to the power minus 15 minus 5s divided by s plus 3. This line should be straight. And then minus Laplace transform of t is 1 over s, e to the power minus 5s is outside, and minus Laplace transform of 1 is 1 over s square, sorry, and Laplace transform of 1 is 1 over s with the 5, so e to the power minus 5s. This is s, this is s, these are all s. So the Laplace transform of the function which we started out with is this. This is the answer. And I haven't used any integration in this. No integration. But the same thing you can do by integration also. If the function is easy, you can do by integration. But sometimes you might get, instead of this, such a simple function like cosine also here, or sine also here, then it would be a lot of work to get to that expression in terms of integration. You have to do integration by parts, maybe many times. Now here, if we go back up and see, we first rewrite this in a heavy side function. It gave us a function in one line, and once we have in one line the function, we applied the linearity, split it. Then once we split it, we use this formula up here. We found out what is the value of a, which was 5. F in this case was e to the power minus 3t. So we translated exponential function multiplied by e to the power minus 5s, which is this. Then again we applied the Laplace transform of this term, multiply e to the power minus 5s. Here now the function was t instead of e to the power minus 3t. Then again using linearity we split all the terms, and we have to just apply to the Laplace transform to the basic fundamental functions like t, 1, e to the power minus 3t, and simplify it and get the answer. Now the domain of this function in terms of Laplace transform will be what? So here s has to be greater than 0, here s has to be greater than minus 3. So at s greater than 0 is fine, because minus 3 is lower than 0. So if you go to the intersection, that would be the domain. Okay, so this is how you can do the problem. No integration is required, and in the differential equation you will end up getting this. I would like to ask you one quick question at this moment. Give me the translation, and I ask this question because it's, even though it's a simple, but it's important. And don't speak out the answer, just write it down. Function is 1 and I want the value of ft plus 5. Translation of this function.